Good morning students. Today we are going to discuss few important topic from chapter current electricity. It is chapter 3. Now the topic which we are going to discuss is very important for exam point of view. Now the topic is your relation between drift velocity and current. Now the drift velocity already we have defined in our previous class. That is your average velocity of the free electrons when electric field is applied. And it acts opposite to the direction of the electric field. Now few in board exam basically apart from the statement part you give more emphasis on the expression, because an expression carries mark whereas statement does not carry any mark. So in this figure what we have considered a conductor and a source is connected whose potential is V and the conductor is of length L. Now an electric field is operated on the conductor from left to right, and electrons moves with the velocity, drift velocity, which is nothing but the average velocity of the free electrons from right to left. Now number one expression already we have defined in our previous chapters, that is E equal to minus dV dr. So here we are going to use this expression in magnitude. So dV is the potential and dr is the distance. So here in this case L is the length of the conductor and V is the potential which is applied across the ends of the conductor. So E equal to V by L. Now second expression we have considered again from the formula, distance equal to speed into time. So here distance is your L and speed is your drift velocity, so time is your distance by speed. The third expression, already known expression, we have defined in our last class, current I equal to Q by T. Now Q is the charge enclosed in the conductor. So if I ask you to define the total charge enclosed inside the conductor, what you have to consider? You have to consider number density. So small n is your number density. It means the number of electrons per unit volume. So here volume is your AL, where A is the area of cross section of the conductor. AL is your volume, N is the number of electrons per unit volume. So it gives you the total number of electrons, and each electron carries a charge E. So finally you are getting I equal to NeAl by T. So Q is your total charge, N is the number of electrons per unit volume. So NeAl. So here we are considering the magnitude of the charge of the electron. Otherwise you can use the sign minus E in place of E. So NeAl in place of T we have used L by Vd. So on simplification you are getting NeAVd. So this is the expression which is in the topic, the current and drift velocity. N is the number of electrons per unit volume. So you can further extend this expression by substituting the magnitude of the drift velocity. So drift velocity magnitude is your E tau by m. You can avoid the negative sign. Now if you substitute drift velocity in the expression, you are getting NeA, and in place of Vd, E tau by m. So finally you are getting Ne square Ae tau by m. So this is the expression by substituting drift velocity in the expression 3. Now let me extend this expression further. E equal to V by L is already there, so we are going to substitute in place of E V by L in this expression number 5. So if you substitute E equal to V by L, so it comes out to be your Ne square A tau by m V by L. So from here you can find out V by I. So if I calculate V by I, it comes out to be mL by Ne square A tau. So again you can go for the Ohm's law, that is your V equal to IR. I think most of you know Ohm's law, you have got in lower class, maybe in class 10. R equal to V by I. So R equal to V by I. So in place of V by I you can write mL by Ne square A tau. Number 8 expression, R equal to rho L by A. So again this expression is known. Rho is your specific resistance. So if you compare 7 and 8, you can get rho, and rho is nothing but is your m Ne square tau. So you can define the expression for specific resistance from the expression of drift velocity, or in terms of relaxation time, the relation for the specific resistance. Further, you can find out the more expression, but the basic equation is this all. So you can rearrange this expression to get some other expression. So these are all important expression, because number 3 till 3, if in exam it is asked current and drift velocity, then you have to define till number 3. But these expressions are important because numericals are there. So in numerical it may be asked to define the resistance, and the rest parameter is given to you. So you have to use this expression, ml by ne square a tau. Tau is your relaxation time, already you have defined. So please do this simple mathematics. It's a very important for exam point of view. Now the next topic which you are going to define is your Ohm's law, and this is very common. I think potential is proportional to current under constant temperature. So this part we have written, the current I flowing through a conductor is directly proportional to the potential difference across the ends of the conductor, provided the physical condition. Physical condition may be temperature, pressure, strain, but basically we used to consider temperature of the conductor remain unchanged. So it is under the constant temperature. So I proportional to V you can write, that is correct, or V proportional to I you can write, that is also correct. So V proportional to I equal to gives you V equal to IR. So R is the constant known as the resistance of the conductor. So you can define SI unit. SI unit of resistance is ohm, and ohm you can define that is your 1 volt by 1 ampere. So if someone asks you what is 1 ohm, what you will define? It is the resistance of a conductor that arises when a potential difference of 1 volt applied across the ends of the conductor that causes a current of 1 ampere. So this expression you can use to define the resistance 1 ohm. So dimension formula for resistance, so you have to put the dimension for volt, that is your work done per unit charge. You can use that one, and finally ultimately we'll get the expression m1 L2 t minus 3 a minus 2. You try this one, it's very simple, and current is your A. Now the next part which you can try to define under the node, that is if we consider a conductor of larger area of cross section, what happens basically, if the area of cross section is high, there may be the possibility of more number of electron may come through that area of cross section. If more number of electron comes out through that area of cross section in unit time, then more charges in unit time, it means more current. So more current means less resistance. So with respect to area of cross section, resistance is inversely proportional. And with respect to length, definitely it's very if the length is very high, then there may be the less possibility if I push an electron from one end so that it reaches to the other end. You have to give more force, is not it? So that's why if the length increases, resistance also increases. So that's why two expressions are proportional to L, number 2 are proportional to 1 by A, combining are proportional to L by A. So R equal to rho L by A, where rho is a specific resistance. And in this expression, volume is constant if you consider a conductor, and if you stretch it, it means A1 L1 equal to A2 L2. So this one also you can use for the numericals. In sometime it is asked in exam, a conductor is there or a wire is there with area of cross section A1 L1. If you stretch it, how do the resistance changes? So you can use this parameter A1 L1 equal to A2 L2. So this is all about this topic, and these topics are very important. But before winding, please download the videos at the very starting of your class, because due to technical problem maybe these videos may be deleted. So before deleting this video due to technical reason, please download it at that very day of your class. So this is all about, please go through this one. Thank you.